So here in section 8.7, we're going to be calculating some type 2 error probabilities. That is the value beta here. So let's consider a hypothesis test with alpha is 0.05, n is 40, and s is 20, given sample information. Our null is mean equal 250. Our alternative hypothesis is that mean is greater than 250. Our test statistic is going to be x bar minus 250 over sigma divided by root n. And then our rejection region from the common rejection region table, z greater than 1.645. So let's go ahead and calculate our standard error here of the sampling distribution, sigma x bar. That is sigma over square root of n. And we don't have sigma, we've got s, so we can use s divided by square root of n to approximate. So that's 20 divided by square root of 40. And if we plug that in the calculator, .1623. So recall here that a type 2 error assumes that H0 is false, and then beta is the probability of accepting H0 when it's false, which is going to be the area of the acceptance region. So since H0 is false here, for any mean that's greater than 250, a different value of beta is going to exist for each one of those means greater than 250. So if the null hypothesis were true, then our mean at the middle of our sampling distribution would be here at 250. Alpha is 0.05, so that's our rejection region right there of area 0.05. And then the first step in finding beta is to find the x value here that's at the cutoff for the rejection region. So that's step 1, is to find x0 is what we'll call it, which equals the cutoff or the boundary of the rejection region. And we can use inverse norm to do that, right? So inverse norm, and then our left area, if this is 0.05, then this area of the acceptance region over there is 0.95. So 0.95 is our left area, and then we are using z distribution here. So our mean is 250. And then our standard deviation up above was 3.1623. And let's go ahead and compute that. So second variables, we want inverse norm, number 3. Left area, 0.95. Mean, 250. Standard deviation, 3.1623. Make sure it's left that's checked, 255.2. So that's this value here. That's how we got that. So find the x value for the cutoff of the rejection region. And then, again, any H0 is false for any mean that's greater than 250, and we're assuming H0 is false in order to calculate beta. So one possible alternative would be that the mean is 253. So this is what we call the alternative distribution. It's got a mean here of 253 at the center of the distribution. And then in that alternative distribution, we want to find this shaded area, which is the area of the acceptance region, and that is beta. So step 2 is that beta equals the area of the acceptance region in your alternative distribution. And for us, we calculate that area. This is a approximately normal distribution, the sampling distribution, so it's going to be normal CDF. And then your lower cutoff minus infinity, we'll do negative 10,000. Your upper cutoff, that's the 255.2. And then in this alternative distribution, our mean is 253, but standard deviation still 3.1623. So let's go ahead and compute that. So we're going to go to second variables. We want normal CDF, negative 10,000. Up to our 255.2. Our mean is 253, we're assuming, and 3.1623. 0.7567. So there, 0.7567 is beta. Okay, so here's another alternative distribution. What if the actual mean was 256? What would be the area of the the area of the acceptance region in this alternative distribution with mean 256? So we've already got the 255.2. You just need to redo step 2. So why don't you pause the video for a second and try that. Okay, so our beta here in this alternative is the area of rejection region, so normal CDF. And your negative 10,000 is the same. And your 255.2 is the same. See this 255.2, that's going all the way down here. That's our right cutoff. But now our mean is 256. Standard deviation the same. So the only thing that changes is that mean. So let's key that in the calculator. So second variables, normal CDF again, and we just have to change our mean to 256. 0.4001. And then let's look at one more. What if our mean was really 259? So here's the sampling distribution with mean 259. Again, this is the 255.2 right there. That's the cutoff for the rejection region in the null distribution. We want this area of the rejection region. So that's going to be same thing as up above, except 259 for our mean. So again, normal CDF. Left hand, negative 10,000. Oh, 10,000. Right hand, 255.2. Mean, 259. And then standard deviation, 3.1623. Go ahead and key that in. So again, the only thing we have to change is the mean here. So 259.1147. So beta here is 0.4001. That is that area. And then beta here, even smaller, 1147. And that is that area. So this is the probability of a type 2 error if the actual mean was 259. This is probability of a type 2 error if the actual mean of sampling distribution was 256, and then this one 253. Now notice here that the area of the non-rejection region or the acceptance region, that beta decreases here as mu increases. So note that the probability of a type 2 error decreases as the actual value of the mean increases. So our means increased from 253 to 256 to 259, and we saw beta go down each time, 0.7, 0.4, 0.1.